Okay, we are starting a new unit today. It is on rationals. Okay, so I want you to look at your notes, look at the worksheet you just got. What do you think rationals are?
X over something.
X over something. Yes, or something over X. So they're all fractions, though. Do you see that? They are all fractions. There is an X in some piece of the fraction. It could be the numerator, it could be the denominator. Okay. What we are going to do is we are going to solve them first, and then we're going to graph them later. Why am I going to solve before I graph? What part of solving is the graph? What do we always solve for? X. So what do you think part of the graph is that we're getting? Which one? The X-Intercepts. Yes, it is the X-Intercepts. Okay, so we're solving for X today. So when we graph next week, that's part of our graphing. Okay, so finding X is finding an X-Intercept. I know you don't love fractions, but we got to remember what to do when all of my denominators are different. Okay, so this is the first one that you got. So here, my X's are on the top. My denominators are 9, 6, and 2. Okay, what has to happen with the fractions before I can start adding and subtracting them together? They all have to have the same denominator. So in this case, 9, 6, and 2, what common factor do they have? Yes, Sal tells us 18. Y'all agree? Yes. So what do I have to multiply my first fraction by to make 9 18? 2. What do we have to multiply? I'll do it like this. My middle fraction to make my bottom an 18. 3. How about the last one? A 9. Okay. So looking at that, do you agree that all the denominators now equal 18? 2 times 9, 3 times 6, 9 times 2. They're all 18. Yes. So because, and I guess I got to do it to this last one. It's not going to change anything, but I got to do it to all pieces of the fraction, technically. I guess I should do 18, shouldn't I? Okay. So when I do that, our denominators are gone. I can just add and solve my numerators. Okay. So your fractions only exist until your denominators match. Once they match, all you have to do from there is solve our numerators. So in this case, we have 2x squared minus 3x minus 9. Okay, once we get this point, it's still equal to 0, we're going to factor. Okay, how would we factor this one? The slip and slide stuff. Okay, so if we slip and slide, this gives me x squared minus 3x, and then that gives me what, minus 18? All right, what multiplies to give me a negative 18, but adds to give me a negative 3? Some kind of a 6, some kind of a 3? Negative 6, positive 3? Slide that 2 back out. We end up with x minus what, 3? And then 2x plus 3. So why do I say my answers are positive 3 and negative 3 halves? Where did that come from? Good. From this step to this step, you got to make each piece equal to 0 and get x by itself. So we had to add 3 over. My other one, you had to subtract 3 and then divide by 2. Yes? No? Because you have to subtract the 3 over and then divide by 2. When you have 2/3 plus 3 equals 0, you subtract the 3 over. Then you divide by 2. This becomes x minus 3. This piece becomes 2x plus 3. Does that help? Okay. We good? All right, let's do another one where we have our numbers on the bottom. All right, this time we have 3, 6, and 2. What is their what common denominator can I make them all have? Make them all have a 6. Good. So what do I need to multiply 3 by to make this 6? A 2. And if we do it to one piece, we got to do it to the other piece of my fraction. What are we going to multiply the middle one by? It doesn't have to be anything, right? Technically a 1, but it's not going to change it, right? And then how about my other side? 3. Do it to one piece, we got to do it to the other. So do we agree all my denominators are a 6? Yes, so once that becomes true, we can ignore that now because just my numerator will help me solve for x. Okay. In a minute, when there's x's down there, we'll have to do something different. But as of right now, we're good to go. So now I'm working with 2 times x plus 1 plus x plus 1 equals 3 times the 2x plus 1. All right, so make your denominators match, and then we can focus on our numerators. All right, so what do you think we should do from here? What? Get them together, combine like terms. I heard distribute. Yes, so let's distribute the 2 into this piece, distribute the 3 over here, and then we do need to get our like terms together. I see a 2x and an x on this side. I see a 2 and a 1, so let's get those together. Do I have to factor with this one? No, I didn't have an x squared, right? No x squared, I don't have to factor. So what am I going to do to get x by itself? Which we're not going to factor. We're going to move stuff around. All right? We subtract 3x over, right? It's gone from here. We get 3 equals 3x plus 3, right? Then when you subtract 3 to get back on this side, what happens? It's 0. So we have 0 equals 3x. So when we divide by 3, we just get x equals 0. Okay. And again, what's nice about these, you can always plug them back in and check. Okay. 1 over 3 plus 1 over 6 should equal 1 over 2. You can type those in and check always. All right. I want you to try the next one because the next one also has numbers on the bottom. So we have 5, 2, and 10. So what's our common denominator going to be? 10. So I want you to bring in the factors that's going to make all those match. Well, you have to factor with this one. Do you get an x squared? Yes, so there will be factoring involved. The what? Interesting. All right, so let's make sure that we multiplied our first piece by 2. That's how 5 becomes 10, right? Multiplied my middle piece by 5. My last piece was already 10. Once my denominators are the same, all we focus on is our numerator. So here it's 2 times 2x times 3x plus 1. My middle piece is now negative, because my negative was already there, so that drops. Negative 5 times x plus 1. And then multiplying this last piece by 10. It's not going to change anything. What am I doing? You don't multiply it by 10. The denominator is already 10, so the 1 is still there. I apologize. We don't change the last piece at all. It already had 10. All right, let's combine like terms. Or actually, we need to distribute first. So this becomes negative 5x minus 5 over here. 2x times 3x gives me 6x squared. And then 2x times 1 gives me 2x. Still have to distribute one more thing. This 2 gets distributed. So we have 12x squared minus x minus 6. We will have to factor. Some of you got something that you couldn't factor. Be careful. Now, it could happen, in worst case scenario, what can you always use to solve a quadratic? The quadratic formula. If you have to, it's there. We try not to do that to you, but it is a thing that you could always use. All right, let's factor this baby. You want to do slip and slide? You want to do the box? What do you want to do? Slip and slide? Yes? All right, so let's slip 12 to the end. That gives me x squared minus x minus what, 72? Equals 0. All right, numbers that multiply to give me 72 but can somehow add to give me a 1. There you go, -9 and +8. Yeah, and then we're going to slide my 12 back away. 9 over 12 simplifies to what? 1 over 4? Not 1 over 4. 3 over 4. And then 8 over 12 simplifies to what? 2 over 3? So that's going to give me 3x minus 4 and 3x plus 2. Oh, what did I do? Put those in the wrong spot. That's what I did. All right, so what are my x-intercepts going to be for this graph of rational functions? Positive 3/4, I heard that. And negative 2/3. Good. You could. Yeah, you could. Good question. He said, why can't I just keep it x minus 3/4 and then just add the 3/4 over? You can. You can leave it that way. So how do we do with the third one where your denominators were still just numbers? Having fun yet? Yeah? Alright, so our next one is the first one with something else besides just numbers, right? Down on the denominator. Here we go. So, first things first. I see 10 over x squared minus 4 equals 1 minus x plus 2, right? I have to make a note to myself. Because there is an x in the denominator, there are certain values I can't be equal to, right? Because I cannot divide anything by 0. So when I solve, I know that this rational will not touch the x-axis at 2 or negative 2. Okay? Because if I were to factor this difference of squares, it becomes x plus 2 and x minus 2, correct? So, therefore, if I plugged in a positive or negative 2, it would make one of those denominators 0. We cannot have that, right? So that's our new step if we have x's in my denominators. We have to make a note of what x cannot be equal to. It's called an extraneous solution, right? Where we cannot. In our actual graph, it's going to be a hole or a break. So remember our piecewise functions where you had holes and stuff? That's where they come from. It's the piece that it's not allowed to be equal to. All right. So now, looking at this, I have 3 denominators, correct? This one is technically x plus 2, x minus 2. This denominator is really 1. And then my last denominator is x plus 2. So, what's going to be my common denominator, do you think? And x plus 2 and x minus 2. So what a common factor here is going to be all the factors together. See how my first one and last one have the x plus 2? My middle one is just a 1. So my first denominator has all the pieces it needs. Am I going to multiply my first fraction by anything? 1 technically. I could do 1 and it wouldn't change it, right? How about my middle guy? What piece of this denominator is it missing? Both of them. So my middle piece needs the x plus 2. It also needs the x minus 2. My last piece, what does it need? It needs the x minus 2. Okay. I'm going to show you the reason why we get to just, instead of doing all the pieces every time, why we're going to just plug in the piece we miss. Okay? Because look, if I multiplied all my numerators by my common denominator, would we agree here that those cancel out? And you're left with just 10. This middle piece, nothing cancels with my denominator. So we still have x plus 2 times x minus 2. My last piece, my x plus 2 was already down here, so all I need is the 1 times x minus 2. So that shows why we can eliminate our denominators, because you're technically bringing it into both pieces, so that's why they get to cancel. Questions on that? Does that make sense? Yeah, I'll take it for right now. I'll take it. All right, what do you think we're gonna do from here? I think you mumbled combine like terms. Is that what you said? Or multiply? Distribute? Yeah, let's multiply x plus 2 and x minus 2 in the middle. That gives us our x squared minus 4. And then I also took this negative and distributed it to x and minus 2. All right, we see an x squared, so we know we're going to have to do what with this problem? We're going to have to factor. So I need to make everything on one side and make it equal to 0. So move it all over. I moved my x back in the middle. I combined my negative 4 and 2 together, and then you also had to subtract 10 from it. So 2 minus 10 was negative 8, and then this minus 4 in the middle gave us the minus 12. Put it in standard form. We can factor this. We don't need to slip and slide. What multiplies to give me negative 12 but adds to give me a negative 1? 4 and 3. Okay, so I need one to be negative. Which one's it going to be? Negative 4. So 0 equals x minus 4 and x plus 3. So when I solve for 0 on each piece, that means x equals positive 4 and negative 3. And I can have those, right? Because my only restrictions were 2 and negative 2. So these are good. We like them. They will work. So when we graph our rationals, we know it's going to cross our x-axis at 4, negative 3. We also know there's going to be holes or breaks somewhere where x was 2 and negative 2. It won't be on the axis, but it will be in the graph when it crosses that place. All right, was that okay? Still okay? All right. Any questions for me at this point? Yes?
Will always be like the first value that you find, or the value with the squared in it to find your extraneous solution? To see what it would be?
You'll have to find all the factors of all the pieces.
Oh.
Yeah. And usually, like, when I factor this, I'll probably get that and that.
Okay.
Does that make sense? So sometimes this one is made up of those two together. Okay. So it kind of works for them all. I would just make sure it does. You've covered each denominator. All right. My next one, we have 1 over x minus 1 plus 1 over x plus 2. It is equal to 3 over x squared plus x minus 2. When I see quadratics like this, I'm going to factor them. So I need to make sure that all my extraneous solutions are being covered. What multiplies to give me negative 2 but adds to give me a positive 1? Plus 2 and minus 1. Notice that that's your other denominators. Kind of helps you out, right? Bless you. Bless you. Bless you. All right. Bless you. My goodness. Alright, so looking at my denominators, when I solve for x, the only values that are restricted for us is going to be positive 1 or negative 2, because that would make my denominator 0, which is, we can't have in a fraction. Alright, what's going to be my common denominator? The x plus 2 and the x minus 1. Those together give you your common factors. You have to have each. Okay, so look at your different factors. Those together give you your common factor. Okay, so I'm going to show you again like I did last time. I'm just going to bring in x plus 2 and x minus 1 to all of them. If you still want to think to yourself, I only want to put in what's missing, like we did for our numbers, you can still do it that way. Like if you recognize the first one only needs an x plus 2, then you can multiply the first piece by only x plus 2. Okay? I'm just showing you a little bit more detail here. So when I bring in my common factor to all of them, my first one already has the x minus 1, so I don't need that anymore. My middle piece already has the x plus 2, not going to need that factor. My last one has both of them, so I'm not going to change the last one at all. So that means I'm left with 1 times x plus 2, right? Plus 1 times x minus 1, and then equals to 3. If you want the ones here, you can have them. You do not need to. It is your choice. I'm also always putting them in parentheses because, like the one before us, if there's a negative, we need to make sure we distribute the negative all the way through it. All right, am I going to have to factor this time? No, I am not. I'm not going to get an x squared. When I combine like terms, I actually get 2x. And then 2 minus 1 gives me 1 equals 3. We got this. What's x going to equal? Well, subtract the 1. You get 2x equals 1. X equals 1. Am I allowed to have x equals 1? No, I'm not. That is not allowed. So because the only value we got was one of my extraneous solutions, this one does not have one. So next week when we graph them, the break or the hole, that remember we saw in our piecewise functions, that break or that hole is going to happen on the x-intercept of 1. So like if this right here, I'll give you a hint. It'll be like this. It'll stop. It'll give a hole, and then it'll keep going, kind of thing. That's how we know where to put the holes in our graph. Yes, no, maybe? Ready for one on your own? You want to try? You want to try this one? Let me help you start it. Yes? Okay. Why did I say negative 3 and 5 can't be solutions? Yeah, that would make some denominator equal 0. I can't have that. Okay. What factors do you see in the denominator? X plus 3 and x minus 5. So what are you going to multiply each piece by? X plus 3 and x minus 5. Use all the different pieces that you see. Alright, I'll help you out with one more little step, and I'm going to make you do the rest. What's the only piece I'm going to use for the first fraction? The x minus 5, because the x plus 3's will cancel. How about my middle piece? We just need the x plus 3. And how about the last piece? We only need the x minus 5. So we end up with 1 times x minus 5 plus 1 times x plus 3. It's going to be equal to 1 minus x, which was already here, multiplied by the x minus 5 that we're bringing in. You need to combine like terms on this side to give you 2x minus 2. My other side, when I FOIL, I'm going to make sure that I put them back in standard form. So I know when you go across, you get x minus 5, and then plus x. Nope, I don't get plus x. Boop, boop, boop. We get negative x squared plus 5x. Make sure you put it in standard form. So your x squared comes first. X plus 5x is 6x. And then minus 5 is on the end. I'm going to keep helping you. I see an x squared, so we know we're going to factor. But I have a negative x squared. How can I want to move it so it's not negative anymore. So instead of bringing 2x and 2 over to my trinomial, how about moving all the trinomial pieces to the other side? That way my x squared becomes positive. I'm going to add x squared over here. I'm going to subtract 6x from the 2x. And we're going to add 5 to the negative 2. So now my x squared is positive. Now we can factor it. Multiplies to give me 3, adds to give me negative 4. Negative 3, negative 1, good. So what does x equal? Positive 3 and positive 1. Can I have both of those? Yes, I can. Yep. All right, questions at this point? Is it getting a little bit easier each time? A little bit. All right, here's the next one. All right, I said this time that 5 and 2 can't be my solutions. Where did the 2 come from? Because I only see a 5 down there. And it's not this guy, because that's technically over 1. Good. When I factor this, nothing hurt over here also. That was our other factor when we factored this piece right here. X minus 2. So that's how we know that 5 and 2 cannot be a solution for this problem. I'm going to pause. You're going to work this one out. You can do it. All right, so look at the TV screen. See if we are matching up to this point. If you're good, I'm going to push pause again. You're going to keep going. Get all your pieces on one side so you can factor because you see an x squared. All right, so from here we need to combine like terms. So I will bring my 3 and my 20 together. I'm also going to subtract x squared. I'm going to add 6x. I'm going to subtract the 8. I want everything together to make it equal to 0. So it becomes x squared minus 8x plus 15. Okay, so we subtracted x squared over here. I added 6x to this piece. And then I subtracted 8 from 20, but then I also added it by the 3 that's on in the very front. So 20 minus 8 is 12, but then plus that 3 gave me that 15. All right, now we can factor. What are the pieces that are going to multiply to give me 15, but add to give me negative 8? Negative 5 and negative 3. Good. So that means my solutions are what?
3.
Ooh, good. Why is it just 3? Why can't I say 5 and 3? Because at the very beginning, we said x could not be 5 or 2. Well, we got 5 and 3, so 5 is out. 3 is our only answer. Good job. Good. We only have one more, correct? All right, how about you do it from start to finish? You got it. You got this last one. We have 1 over a minus 3 plus 2 over a squared minus 9 equals 5 over a plus 3. I'm going to push pause. You do these. Whenever you see a squared happening in your denominator, you got to factor that first. Okay? A squared minus 9, you have to be able to recognize that is a difference of squares. That is a plus 3 and a minus 3. You have to factor that. That is where all my factors come from, and my restrictions come from. So we need a plus 3 and a minus 3 brought into each piece. A plus 3, a minus 3. A plus 3, a minus 3. A plus 3, a minus 3. Alright? I'm going to stop. You're going to keep going. Alright, I saw lots of good things. Lots of good things. We should be getting 5 for this one. A equals 5. Yes. In my first piece, let me show you. In my first piece, I already had the a minus 3, so I need just 1 times a plus 3. My middle piece already had both of them, so I'm not going to bring anything to 2. 2 is going to stay. Equals, already had a plus 3, so I'm going to do 5 times a minus 3. So all my denominators got canceled out. Numerators are left over. Combine like terms, so on the left side, we're going to do the 3 plus 2. On the right side, we're going to distribute the 5 to a and negative 3. If I were you, I would subtract a, but then also add 15 over. So you get 20 equals 4a. I subtracted a from over here, added 15 to this side, and then divide by 4, we get a equals 5. And are we allowed to have a equals 5? Yes. What are we not allowed to have? 3 or negative 3, so we are good. So this rational function will cross my x-axis at 5. Questions about any of those? I saw lots of good ones when I walked around. Alright, so again, your homework tonight is just the front page, so you will only be doing 1 through 8. Alright?